Hello, my name is Andrew Just, and in this module on Forecast Builder, we are going to discuss the usage of snow level within Forecast Builder. And I'd also like to take this opportunity to thank a lot of the coordination I've had with the Western Region Mountain Zoos as well as Central Region Mountain Zoos on integrating snow level into Forecast Builder. So what is snow level? The definition is that it's the elevation that snowflakes begin to melt on descent. Meanwhile, here for the gridded definition, it is simply the height of the wet bulb 0.5 degrees Celsius. Not wet bulb 0, wet bulb 0.5 degrees Celsius. This matches the national blend of models definition and allows a rough approximation of snow level. This takes into account atmospheric temperature and the moisture profile, allowing for evaporative cooling effects. So why do we choose 0.5 degrees C? Well, it's approximately 300 feet below wet bulb 0, which allows time for liquid to occur, resulting in the rain-snow mix. It's also populated as a foundation grid in Forecast Builder. And let's take a look at an example of snow level. Here on the right is from the National Blend of Models. This is just one example. 36-hour forecast here noted from 2017, September 17th. You can see over the Pacific Northwest and into Montana, as well as down towards Salt Lake City area, some lowering of the snow levels as the upper trough moves across. Now in Forecast Builder, here's an example of what this would look like if you populated snow level. Note that this is just a completely different example in terms of the specific values, but just to really demonstrate what it looked like in Forecast Builder. So how are precipitation types calculated with snow level? Well, here is just an example of a fictitious mountain with different lines here showing where you're going from snow to rain, snow mix to rain. So let's move through this diagram here for a little bit. So the first line up top represents the wet bulb 0 line. And anything above that is just going to be all snow. All colder than 0 C through the profile, so you get 100% snow, 0% rain. The second blue line going down the mountain represents the snow level. Again, that wet bulb of 0.5 degrees Celsius. Here, and I should say above that snow level, it's still going to be all snow. 100% pot snow, 0% probably rain. Again, that's about a 300 feet distance between the two. Drop down to the red line here. The red line happens to be matching up with the wet bulb of approximately 1.8 degrees Celsius. And in between that red line and the darker blue line is where you're going to end up in a mixed rain and snow zone. So the probabilities of snow and probabilities of rain are going to equal both at 100%. And that distance is approximately 800 feet, and that's been found through various science and statistical research. And then once you go below that wet bulb of 1.8 degrees Celsius, it's an all rain forecast with 0% snow and 100% rain. Now there are some consistency checks applied with this approach, 2 of them to be specific. The first of which is that if the surface wet bulb happens to be greater than or equal to 2.5 degrees Celsius, then the probability of snow will go to 0% and the probability of rain 100%, an all rain forecast. Basically, this is when there's enough warm air near the surface, saturated enough that you'll end up with just flat out rain. Second scenario is you go through this process from going down the mountain and you end up with a surface temperature less than 0 C. In these situations, the probability of snow is going to be assigned 100% and the probability of rain 0%. But note here that this step is subject to revision to account for dry environments with temperature inversions, so be prepared that this could be updated over the coming months. So as we've gone through these 2 slides about snow level, one thing you will have noticed is that there's nothing about freezing rain or sleet. Just on the topic of freezing rain, there's none of that with this approach. So you might be wondering, how do I get freezing rain? Because a lot of offices that deal with snow level issues can also end up dealing with things like freezing drizzle or maybe even freezing rain. So the best way to do that is to create a prob-ice present grid. And in Forecast Builder, you will notice in the foundation grid step that snow level and prob-ice present are right next to each other. And that's intentional. because of these situations for freezing rain and drizzle. So how do you do this with prob ice present? Well, if you want to maintain just the snow level approach, don't even bother doing a prob ice present grid. Or if you do create one, keep the value at 100. That's shown in the image there to the right, in the upper left across much of Minnesota, where that would only be a rain or snow scenario. Now, if you want to get that freezing rain or drizzle in, look at the bottom right where you've got 0 values. That's a forced liquid forecast. Here you're saying there's no ice in the cloud, so you're going to have to go with all freezing rain or freezing drizzle, depending upon the droplet size. There's a good training module in the Forecast Builder training plan on using the prob ice present grid. I would highly recommend going through that module so you can learn more about this prob ice present grid and how to utilize it even more so. There are a few more scenarios here to discuss. The first is freezing rain and saturated environments. Forecasters really should strongly consider switching to the top-down approach, or at least include prob ice present grids in these environments. For example, here's the sounding where you've got, as you can see, pretty much fully saturated, and then there's a warm nose and a cold dome below that. These would be a classic type freezing rain and sleet soundings that you may run into. Note, however, that over the mountainous terrain, that the top-down approach can be a little tricky just because of vertical and horizontal resolution within the models of the terrain. So just be cautious of that. And valley inversions with high freezing level is another scenario to be aware of. If your surface temperatures are less than 0°C, as you saw a couple slides ago, that will result in snow. But if your confidence exists that there's going to be actual rain, then adjust those temperatures above freezing. A good scenario like this is that maybe you have a pop of, let's say, 20%. Your temperatures are in the 20s in the valley because of what's probably end up being radiational cooling, but if that pop should verify, there's probably going to end up being more clouds, so the temperature forecast is off. So these are what the scenarios that we're kind of running into. I just want to kind of represent that by this little crude image that, if you had thrown a cloud deck across that valley probably isn't going to get down to -3°C. It's going to end up being something warmer than that. So just, again, something to be aware of. And here are some references, and thank you for watching.